Hello everyone. Today I'm here with you all with one of the topic of class 8 maths curriculum, that is algebraic identities. In this video we will be learning about what identities is and how we can find the product of some special type of expressions without actually multiplying it. So let's start with the topic, that is your algebraic identities. So first of all, what identities is? Identities are the algebraic expressions which are true for every value of the variables used in it. In the algebraic equation, whatsoever the variables are there, whatsoever the value of these variable we will be keeping, if for every value of the variable your LHS is equivalent to the RHS, then we say such type of algebraic equations to be your identities. We will be seeing what identities are. Now the special products, the multiplication of certain type of expressions can be obtained by direct or shortcut method. That means we need not to multiply it if without actually multiplying it by the direct or the shortcut method we are getting the multiplication of certain type of expressions, then it is your special products. The examples are your first is your x plus a multiplied by x plus b could be written as your x square plus x multiplied by a plus b plus ab, where a and b could be any of the number. Like if I am going to take an example, suppose I am multiplying your x plus 2 multiplied by your x plus 3. Over here, instead of a, it is your 2, and instead of b, it is your 3. What we have taken is, instead of a, we have taken 2, and instead of b, we have taken 3. If simply we will be multiplying it, then what will be the solution? What will be the product? X will be multiplied by x plus 3 and 2 will be multiplied by your x plus 3. So x multiplied by your x plus 3 plus 2 multiplied by your x plus 3. If we will be solving it further, x multiplied by x will be your x square, x multiplied by 3 will be your 3x, plus 2 multiplied by x will be your 2x, plus 2 multiplied by 3 will be your 6. So it is your x square plus 3 plus 2 is your 5x plus 6. This is the product of your x plus 2 multiplied by your x plus 3. If instead of multiplying it, we are directly keeping in the formula this identity, then what the answer will come? Let's check it out. Over here, instead of a, we will be keeping 2, and instead of b, we will be keeping 3. If directly we are using this identity, then what the formula will be? What your product will be? Your x square plus x. Instead of a, we will be writing 2. Instead of b, we will be writing 3 plus 2 multiplied by your 3. So it is your x square plus 2 plus 3 is your 5x plus 2 multiplied by 3 is your 6. So we can see over here that x square plus 5x plus c, if we have multiplied these two, then also we are getting the same thing. And if directly we have used this formula, then also we are getting the same thing. So directly shortcut method, we can find the product of these type of expressions. Now let's take the second, that is your x plus a multiplied by x minus b is equivalent to x square plus x multiplied by a minus b minus of ab. If over here, instead of a, suppose we are taking this only I am taking a is equals to 2 and b is equivalent to 3. If this is only the case I am taking, so what this expression will become? Your x plus 2 multiplied by x minus 3. And if this is the case, if simply we will be multiplying, we are not using this formula directly, we are simply multiplying it, then what the answer will be? X will be multiplied by your x minus 3 and then plus 2 will be multiplied by your x minus 3. X multiplied by x will be your x square, x multiplied by minus 3 will be minus of 3x, 2 multiplied by x will be your 2x, and 2 multiplied by minus 3 will be minus of 6. Now, if we will solve it further, x square we have taken as it is, minus of 3x plus of 2x, minus 3 plus 2 will be minus of x, minus of 6. This is the product of these two expressions. Now, if directly we are using the formula, then what the answer will come? What we have to take? X square plus x a minus b minus of ab. If we will be keeping the values of a and b over here and this, then what the value will come? X square plus x. Instead of a, we will be taking 2. Instead of b, we will be taking minus of 3. Instead of b, we will be taking your 3. Then minus of 2 multiplied by your 3. So it will be x square. 2 minus 3 is your minus of 1. So minus of x minus 2 multiplied by 3 will be your 6. So if directly we are using, then also we are getting the same value. If we are multiplying it, then also we are getting the same value. So instead of directly multiplying it, we can directly use the formula. Directly we can keep the values over here, and it is your direct method or your shortcut method. This is your third expression, that is your x minus a multiplied by your x plus b. If these two are the expression and if we are multiplying these two, so directly without multiplying we can apply this identity or this formula we can apply. So x minus a multiplied by x plus b could be written as x square minus x a minus b minus of ab. Now let's take an example. Again I am taking the same values. A is equivalent to 2 and b is equivalent to 3. So third case I am taking. So this will become x minus of 2 multiplied by x plus 3. This is, instead of a I have taken 2, instead of b I have taken 3. So it has become x minus 2 multiplied by your x plus 3. So if we will be multiplying it, its value will be, its product will be, x will be multiplied by your x plus 3 and minus 2 will be multiplied by your x plus 3. X multiplied by x will be your x square. X multiplied by 3 will be your 3x. Minus 2 multiplied by x will be minus 2x, and minus 2 multiplied by 3 will be your minus of 6. So it will be x square plus 3x minus 2x will be plus of x minus of 6. This is the product of these two expressions. Now if instead of multiplied we have directly applied the formula, so what the value would have come? It is your x square minus of x a minus b minus of ab. If I'll be keeping the values of a and b over here, what the value will come? X square minus x. Instead of a we will be taking 2, instead of b we will be taking 3, minus of 2 multiplied by 3. So it will be x square. 2 minus 3 will be your minus 1, and minus 1 multiplied by this minus sign will become your plus of x, and minus of 2 3s are 6. So the same value we will be getting. So we need not to multiply it if it is in these forms. If your expressions are any of these forms, we need not to multiply. We can directly keep the values in your RHS part and we can get the value. Now let's see the fourth. Here we won't be multiplying it. Directly we will be using the formula. Instead of a, we will be keeping 2 again. Instead of b, we will be keeping 3 again. That means if your question is x minus 2 multiplied by x minus 3, then what the product of these two expressions will be? It will be your x square minus of x a plus b plus of ab. This is the RHS part. So here we will be keeping x is equivalent to, a is equivalent to 2 and b is equivalent to 3. So what it will be? X square minus x 2 plus 3 plus 2 multiplied by 3. It will be x square. 2 plus 3 will be 5. So minus of 5x plus of 6. This will be the answer if we will be multiplying these two expressions. So directly we can write the product of these two expressions without actually multiplying it. So this is how we can use these formulas, these identities we can use directly. We need not to multiply. We can directly take the RHS part, and whatsoever the values of a and b are given to us, we can replace it, and instead of multiplying it, directly we can get the answer. Till now we have seen 4 identities. Now let's see some more algebraic identities. The fifth identity is your a plus b whole square is equivalent to a square plus 2ab plus b square. Whatsoever the value of a and b, it will hold. For each and every value of a and b, this identity will be true. That means your LHS part will be equivalent to your RHS part. Let's take an example. Suppose instead of a, I am taking your x, and instead of b, I am taking your 2. In that case, your LHS part will become x plus 2 whole square. And if we will be multiplying it, then what the answer will be? Let's check it out. X plus 2 whole square means your x plus 2 multiplied by your x plus 2. That simply means x will be multiplied by your x plus 2. Then plus 2 will be multiplied by your x plus 2. If we will be multiplying it, x multiplied by x will be your x square, x multiplied by 2 will be your 2x, 2 multiplied by x will be your 2x, and 2 multiplied by 2 will be your 4. So it will be your x square plus 4x plus 4. This is the value of your LHS part. Now let's solve it for your RHS even. So RHS part will be, it is your a square plus 2ab plus your b square. We have to replace a by your x and b by your 2. So what the value will come? Instead of a, we'll be writing x. So x square plus 2 times of your x and b is your 2 plus b square. So it will be x square plus 2 multiplied by 2 will be your 4x plus 2 square will be your 4. So the value of your LHS and value of your RHS is equal. So what we can do is, instead of multiplying it, we can directly use this identity. So now let's see another example. Suppose I am saying it is your 14 square we have to find. So 14 square could be written as 10 plus 4 whole square. We can write 14 as your 10 plus 4 also. So 10 plus 4 whole square. Now if we are going to compare this with your a plus b whole square, we can see the value of a is your 10 and value of b is your 4. If we are going to replace the value of a by your 10 and value of b by 4, so what the RHS value will be? RHS will be a square, that means your 10 square, plus 2ab, 2 multiplied by a is your 10 and b is your 4, and plus b square, b is your 4. So it will be square of 10 will be your 100 plus 2 multiplied by 4 is 8 and 8 multiplied by 10 is your 80 plus 4 square will be your 16. So this will become your 196, and we know that the square of 14 is your 196 only. So this is how we can replace a by any of the number or the variable, and we can replace b by even any of the number or any of the variable. If this is the case, directly instead of multiplying, we can use this identity and we can get the answer. Similarly, the next identity is your a minus b whole square. Again, over here even we can keep any value of a and any value of b also. Suppose I am saying that value of a is your 2x and value of b is your 3y. Instead of a, we are taking 2x, and instead of b, we are taking your 3y. If this is the case, what the question will be? It will be your 2x minus 3y whole square. This is your LHS part. What the LHS part is? 2x minus 3y whole square. If we will be solving it, then it will be 2x minus 3y multiplied by your 2x minus 3y. Then 2x will be multiplied by whole bracket, that is your 2x minus 3y, and this minus 3y will be multiplied by your 2x minus 3y. If we will be multiplying it, 2x multiplied by 2x will be your 4x square. 2x multiplied by minus 3y will be minus of 2 3s are 6xy. Minus 3y multiplied by 2x will be minus of 2 3s are 6xy. Minus minus will become plus, 3 3s are 9y square. So 4x square minus 6xy minus 6xy, like terms it is. So minus 6 will become minus of 12xy plus 9y square. This is the product of your 2x minus 3y whole square. If we will be multiplying these two expressions, the answer will be this. Now instead of multiplying, we could have used directly your identity also. What we would have done, instead of simply multiplying it, we could have taken the values of a as your 2x and value of b as your 3y in your RHS. Then what the value will come? We will be taking the RHS part. It is your a square minus 2ab plus your b square. In this case, we have to replace a by 2x and b by your 3y. So it is your 2x whole square minus of 2. Instead of a, we will be taking 2x. Instead of b, we will be taking 3y plus 3y whole square. 2x square means 2x multiplied by 2x. So it will become your 4x square, 2x multiplied by 2x. 2 2s are 4, x square. Now 2 multiplied by 2 is 4 and 4 3s are 12. Minus of 12xy. And 3y whole square means 3y multiplied by your 3y. So 3 3s are 9y square. So we can see that your LHS and RHS part are equal. That means identities are the statement whatsoever the values of the variable we will be keeping for every value of the variables, your statement is true. That means your LHS part is always equivalent to your RHS part. Or we can say we need not to multiply it, directly we can use these identities and directly we can find the answer. Now instead of multiplying, if directly I am using the identity, how we can solve it? Now suppose I am taking an example again. If it is your say 5x minus 3 whole square. So what we can see over here, a is replaced by your 5x and b is replaced by your 3. So what we need to do is in RHS, we need to replace a by your 5x and b by your 3. So instead of multiplying it directly, we can use the identity. Now what the answer will be, what the product will be, I am directly taking the RHS, not multiplying it. So it will be RHS is your a square minus 2ab plus b square. We have to replace a by 5x and b by your 3. So it will be 5x whole square minus of 2. A is your 5x and b is your 3 plus b square, that is your 3 square. 5x square means 5x multiplied by 5x, that is 25x square minus 2 5 is 10 and 10 3s are 30x plus 9. This will be the answer if you will be doing the square of your 5x minus 3. So directly we can write the answer. We need not to multiply it. Directly we can say that the answer of this or our product of these two expressions will be your 25x square minus 30x plus 9. This is how we can prove it even, and we can use your identities even. Now let's understand some more algebraic identities. X plus y multiplied by x minus y is equivalent to x square minus y square. If there is any of the expression in this form, that means we have taken any two variables, one is your x, one is your y. If the product of sum of these two multiplied by your difference of these two, if these type of expression is there, their answer will be, their product will be your x square minus y square. Suppose I am saying that it is your value of x is say 8 and value of y is your 2. We are taking value of x as your 8 and value of y as your 2. Then LHS will be your 8 plus 2 multiplied by your 8 minus 2. This will be 8 plus 2 is your 10 and 8 minus 2 is your 6. So answer is your 60. This is your LHS part. Now if we are taking the RHS part, it is your x square minus of y square. Instead of x we will be taking 8. So 8 square minus of 2 square. 8 is 64 and square of 2 will be your 4. So answer will be 60. So if your expression is in this form, then directly we can say the answer or the product will be your x square minus y square. Product of x plus y and x minus y is your x square minus y square. So if your x, if we are going to replace your x, another example I am taking, instead of x I am taking 5x and instead of y I am taking 3. So your LHS part will become 5x plus 3 multiplied by 5x minus 3. If this is the expression, so instead of multiplying it directly we can say that the answer will be your x square minus y square, where we are replacing x by your 5x and y by your 3. So answer of this, product of these two expressions will be your x square minus y square, that is 5x whole square minus of 3 square. 5x whole square means 5x into 5x, that is your 25x square minus of 9 will be the answer. We need not to multiply it, directly we can say that the answer will be 25x square minus 9. The next identity is a plus 1 upon a whole square. If your expression is in this form, then the answer will be a square plus 1 upon a square plus 2. Let's take an example. Here LHS part is your a plus 1 upon a. So if I am taking Instead of a, I am replacing it by your 2x. If I am replacing a by your 2x, so your LHS part will become 2x plus 1 upon 2x whole square. A plus 1 upon a whole square means 2x plus 1 upon 2x whole square. Instead of a, we have taken 2x. So if simply we are going to multiply it, we are not using the identity directly, we are multiplying it. So what the product will be? 2x plus 1 upon 2x multiplied by 2x plus 1 upon 2x. Because it is a square, so we'll be multiplying it 2 times. So 2x will be multiplied by your bracket 2x plus 1 upon 2x, and this 1 upon 2x will be multiplied by your 2x plus 1 upon 2x. If you will be multiplying it, 2x multiplied by 2x will be your 4x square. 2x multiplied by 1 upon 2x. 2x and 2x both are going to cancel. If we will be multiplying 2x and 1 upon 2x, both are going to cancel, so it will be plus of 1. Similarly, 1 upon 2x multiplied by 2x will be a plus of 1, and plus 1 upon 2x multiplied by 1 upon 2x will be 1 upon 4x square. So it will be 4x square plus 2 plus 1 upon 4x square. This is if we have multiplied it. And if directly we would have applied the identity, then what the RHS part will be? It is your a square plus 1 upon a square plus 2. So instead of a, we will be writing 2x whole square plus 1 upon 2x whole square plus 2. 2x whole square means 4x square plus 1 upon 2x into 2x will be 1 upon 4x square plus 2. So we can see the LHS and RHS parts are equal. So directly, if your expression is in this form, we need not to multiply. Directly we can use the identity and we can get the answer. We need to solve only this much of part. We need not to multiply it because it is an identity. So directly we can replace a by your 2x and we can get the answer. So this is how identities makes our calculation very easy. Now let's see another, that is your a minus 1 upon a whole square. So if this type of expression is there, directly we can say that the product will be a square plus 1 upon a square minus 2. Here we won't be multiplying it, we will be directly using your RHS part. Identity directly we will be using. So suppose your a is replaced by say 5x. If a is replaced by 5x, so your question will be 5x minus 1 upon 5x whole square. If this is the expression which we need to solve, then what the answer will be? Directly we can write it as a square plus 1 upon a square minus 2, where we will be replacing a by your 5x. So the answer will be, directly we will say a square means 5x whole square plus 1 upon 5x whole square minus of 2. 5x whole square means 5x multiplied by 5x, that is 25x square, plus 1 upon 5x whole square means again 5x multiplied by 5x, that will be 25x square minus 2 will be the answer. We need not to multiply it twice, simply the answer will be your this. This is how we can use the identities and directly we can find the product of some special type of your expressions. Now let's take one more example of this only. Suppose I am saying I am replacing a by your say simple number, I am taking 3. So it will be, LHS part will be, your question will be in the form 3 minus 1 upon 3 whole square. This will be the expression that we need to solve it. So if this type of question is there, what we have done is we have replaced a by your 3. This is the replacement we have to do. So solution for this part will be your a square, that means 3 square plus 1 upon a square means 1 upon 3 square minus of 2. 3 square means 3 3s are 9 plus 1 upon 3 square means 9 minus of 2. So 9 minus 2 will be your 7. 7 plus 1 upon 9. So 9 will be the LCM. 7 9 is 63 plus 1, that is 64 upon 9 will be the answer. And if we will be solving it, then what the answer will be? First of all, we will be solving the bracket in that case. This is how we need to solve. We need to apply the identity and this will be the answer. But if we are not applying the identity, we are simply solving it, then 3 minus 1 upon 3 we have to solve it. 3 will be the LCM. 3 3s are 9 minus 1 whole square. That is your 9 minus 1 is your 8 upon 3 whole square. Square of 8 is your 64 and square of 3 is your 9. So this is how we can get it. By any of the means we can solve it, but if we will be using the identities directly, we will be getting the answer. It will always give you your shortcut method. Till now we have seen that how to find the square of the binomials. Now let's see how to find the squares of the trinomials. That means if there are three terms are there, how we can find the square of these type of algebraic expressions. Now let's see, if it is your a plus b plus c whole square, then the expansion of this will be a square plus b square plus c square plus 2ab plus 2bc plus 2ac. This is the expansion of your a plus b plus c whole square. Here a could take any value, there could be any value for the b also, and there could be any value for the c also. They could have any of the values. Whatsoever the values of a, b and c will be there, the same we will be replacing in the RHS, and that will give us the square of the trinomial. Now directly we'll be using the identities. Now let's see, suppose a is your 2x, b is your 3y and c is your say 2z. If a we are replacing by 2x, b by 3y and c by your 2z, so your LHS part will become, LHS will be 2x plus 3y plus 2z whole square. If we have to find the square of this trinomial, that is 2x plus 3y plus 2z whole square, if we need to find, so what the answer will be, directly we will be keeping the values of a, b, c over here. So what RHS part is? RHS is your a square plus b square plus c square plus 2ab plus 2bc plus 2ac. In solving the identities, we always need to write the identity first. First of all, we will be writing the identities whichsoever we are using it. Now we will be replacing a by 2x, b by 3y and c by your 2z. So your answer will be 2x whole square. Instead of b, we will be writing 3y whole square. Instead of c, we will be writing 2z plus 2 into a is your 2x, b is your 3y. Plus 2 multiplied by b is 3y and c is your 2z plus 2 into ac. A is your 2x and c is your 2z. This is how the expansion of 2x plus 3y plus 2z whole square will be. Now we will be solving it further. 2x square means 2x multiplied by 2x, that will be your 4x square. Plus 3y whole square is your 3 3s are 9y square. 2z whole square means 2z into 2z, that is your 4z square. Now 2 multiplied by 2 is 4 and 4 3s are your 12 plus 12xy plus 2 multiplied by 3 is 6, 6 multiplied by 2 is your 12yz plus 2 2s are 4 and 4 2s are your 8, 8xz. This will be the square of your 2x plus 3y plus 2z. If we will be multiplying 2x plus 3y plus 2z by 2x plus 3y plus 2z only, then the answer will be your, this will be the answer. So we need not to multiply it directly, we can use the identity and we can get the answer. Now if instead of positive c, here we have taken all the three a, b and c as positive. If instead of this, if this is the case, like a plus b minus c whole square is there, that means any of the term is your negative. In that case your answer will be a square plus b square plus c square plus 2ab minus 2bc minus 2ac. Wheresoever c was coming, we have taken negative sign. Here minus c multiplied by minus c will become your plus of c square. That's the reason here it is your plus c square, but here minus c will become, these two terms will become your negative. Now let's take an example. Suppose we are replacing a by your say 5x. We are replacing b by your simple, we are taking it to be suppose 2y, and c we are taking as only 3. Simple number we are taking it as 3. So if your expression will become here 5x plus 2y minus of 3 whole square. If we have to find the value of this, here we have replaced a by 5x, b by 2y and c by your 3. If this is the value we have to find for this value, means 5x plus 2y minus 3 whole square we have to find, then what the answer will be? It will be, we can get by this formula, this identity. So RHS part over here is your a square plus b square plus c square plus 2ab minus 2bc minus 2ac. We will be replacing a by 5x, b by 2y and c by your 3. So answer for this will be 5x whole square plus b is your 2y. So 2y whole square, c is your 3. So 3 square plus 2 times of a is 5x, b is your 2y. Minus of 2 into b is your 2y and c is your 3. Minus of 2 into a is your 5x and c is your 3. Now we will be solving it. 5x whole square will be 5 is 25x square. 2y whole square will be 2 2s are 4y square. 3 square will be your 9. 2 into 5 is 10. 10 multiplied by 2 will be your 20. 20xy minus of 2 2s are 4 and 4 3s are 12y minus 2 5 is 10 and 10 3s are 30x. This will be the answer. If we will be multiplying this 2 times, that means 5x plus 2y minus 3 will be multiplied by itself only, then the answer will be your 25x square plus 4y square plus 9 plus 20xy minus 12y minus 30x. So we need not to multiply directly, we can apply the identities and we can get the answer. Now let's see how to find the cubes of the given expressions using identities. Till now we have seen how to find the squares of the given expressions. Now we'll be seeing how to find the cubes of the given expressions using identities. So a plus b whole cube is your a cube plus 3a square b plus 3ab square plus b cube. If we are going to replace a by any of the number or the expression or your variable, or we are going to replace b by any of the number or any of the variable, then expansion of a plus b whole cube will be a cube plus 3a square b plus 3ab square plus b cube. Because it is an identity, so for each and every value of the a and b, this will be true. Now let's take an example. Suppose I am saying your value of a is your, say, we are replacing it by your 3xy, and value of b we are replacing by your 2. So if we have to find the cube of 3xy plus 2 whole is cube, if this is what we need to find it out, what we have done is we have replaced a by your 3xy and we have replaced b by your 2, and we have to find the cube of it. Then instead of multiplying this expression 3 times, cube means we will be multiplying it by 3 times. So instead of multiplying it 3 times directly, we can use the identity and the same answer we will be getting it. So this is how shortcut, this is a shortcut method which using your algebraic identities we can solve it. Now let's see what the answer for this will be. A cube, solution for this will be your a cube plus 3a square b plus 3ab square plus b cube, where we will be replacing a by your 3xy and b by your 2. So it will be a cube means 3xy whole cube plus 3a square. A square means 3xy whole square into b. B is your 2 plus 3. A is your 3xy plus multiplied by b square. B square is your 2 square plus b cube. This will be the expansion of your 3xy plus 2 whole cube. Now if we will be solving it further, 3xy whole cube means 3xy multiplied by 3xy multiplied by 3xy. So it is your 3xy multiplied by 3xy multiplied by 3xy. 3 3s are 9 and 9 3s are 27 x cube y cube. 3 multiplied by 2 will be your 6. 6 multiplied by your 3xy whole square. That means 3xy multiplied by your 3xy. 6 3 3s are 9 and 6 9 is 54. 54 x into x will become x square, y into y will become y square. Now here square of 2, that will be 4. 3 3s are 9 and 4 9 is your 36xy. And 2 cube means 2 multiplied by 2 multiplied by 2, that will be your 8. This will be the answer. If we will be finding the cube of this expression, that means if we will be multiplying this expression 3 times, the answer will be your this. That's why using your identities very easily we can find the products. Now, if it is your a minus b whole cube, in this form your expression is there, then the solution will be a cube minus 3a square b plus 3ab square minus of b cube. Here, suppose we are replacing a by, say I am taking a as your 100 and b we are replacing by, suppose I am saying it is your 5. If a is your 100 and b is your 5, then what your a minus b whole cube will be? It will be your LHS part will be 100 minus 5 whole cube. That means if suppose your 95 whole cube is given to you, we have to find the value of 95 whole cube. So this could even be written as 95 could be written as 100 minus 5 also, and we have to find the cube. So if this is the case, 100 minus 5 whole cube. So a value of a will be 100, value of b will be your 5. It will be checking this a minus b whole cube and this 100 minus 5 whole cube. We can see over here a is replaced by 100 and b is replaced by your 5. So what the answer will be, instead of multiplying 95 into 95 into 95, we can directly solve it using this identity. So solution of this will be a cube. A is your 100. So 100 cube minus 3. A square means 100 is square. B is your 5 plus 3 into 100 into b square is your 5 square minus of 5 cube. Now if we will be solving it 100 into 100 into 100, it will be 1, 2, 3, 4, 5, 6 zeros will come. Minus 5 3s are your 15 and 100 square means 4 zeros will come. Now plus 5 5 is 25. 25 into 3 is your 75, 100. Minus 5 cube is your 5 into 5 into 5, that is your 125. Now if we will be solving it further, first of all these two are positive numbers, we are adding these two numbers, it will become your 7500 and then it is your, this will be the sum of first and third term because both are positive. Then we are adding these two numbers because these two are negative, so we are adding these two, minus of 150,125. This will be the addition of these two, but they were negative, so we have taken negative sign. Now we will be subtracting these two. 10 minus 5 will be your 5. 9 minus 2. 9 minus 2 will be your 7. This will become 4. 4 minus 1 will be your 3. Then it is your 7. Then it is your 10. 10 minus 5 will be your 5. And it is your 9. 9 minus 1 will be your 8. So this will be the cube of your 95. Instead of multiplying 95 3 times, we could have used the identity and we could have find the answer. So this is how, using the identities, various identities, it becomes very easy to multiply your expressions. In whatsoever the form the expression is given to us, we have to check it out that which identity we can apply. Then we have to write the identity and we have to replace the variables by the given question, according to the given question. So this is all about your algebraic identities, and this is all from your this chapter. Soon we'll be coming with the more videos on other chapters of your class 8 maths curriculum. Thank you.